Oh my god. Hi, today I'll be talking about Gay-Lussac's law of gases. Gay-Lussac's law is an ideal gas law where at constant volume, the pressure of an ideal gas is directly proportional to its absolute temperature. In other words, if any gas, is kept at a constant volume, and its temperature goes up, then its pressure will go up, and vice versa. Now, to demonstrate this law, I'm going to be doing an experiment today. Let's get started, shall we? The materials you will need for this experiment include water, a white casserole platter, preferably glass, 2 candles, a glass container, and food dye. First, fill your casserole platter with water. Mix in dye so it spreads evenly. Light your candles and place them inside the container. We'll place the glass container on top of the candles. You can see the water starts to rise, and at one point the candles start to float because of their low density. When we place the container on top of the candles, it creates the constant volume we need to see Gay-Lussac's law take place. At first, the temperature inside the container increases, causing the oxygen molecules hit the walls of the container as they push outwards. At the same time, oxygen is turned into carbon dioxide and water vapor as a result of combustion. Once the oxygen needed to combust runs out, the candle flames go out as well, and the leftover oxygen is pushed down. At this point, the temperature inside decreases and the gases inside decelerate. This deceleration causes them to try and even out with atmospheric pressure, and because the glass container is too tough to collapse, the water rises instead. Gay-Lussac's law can also be explained in the form of a formula. Gay-Lussac's formula is pressure 1 over temperature 1 equals pressure 2 over temperature 2. Or it can also be pressure 1 times temperature 2 equals pressure 2 times temperature 1. In an example, a gas has a pressure of 699 millimeters of mercury at 40 Celsius. What is the temperature at a pressure of 760 millimeters of mercury? First, you'll need to sort out your temperature and pressures. Your first pressure will be 699 millimeters of mercury. Now for your temperature, convert 40 Celsius into Kelvin by simply adding 273 Kelvin. Your answer for your first temperature then should be 313 Kelvin. Finally, your second pressure will be 760 millimeters of mercury, and you will be looking for your second temperature. Finally, rearrange the formula into what you're looking for. In this case, temperature 2. Plug in your pressure 1, then your temperature 1, and then finally pressure 2. Your answer with sig figs should be 288 Kelvin. As a review, we learned that Gay-Lussac's law of ideal gases states that at constant volume, pressure and temperature are directly proportional. This means that if pressure increases, then temperature will increase as well, and vice versa.